In this question, we are given a spinner or the image of something that looks like a spinner with 6 sections, equally divided sections. And that means that the probability of landing on any one of these 6 sections is 1 divided by 6. And then each of these A, B, and C parts are going to ask us different questions about landing on either red, blue, or cyan. And we are asked to find the probability as a fraction in simplest form for all of these parts. Part A says find the probability that Alicia spins red on the first spin and cyan on the second spin. So here we have 2 spins or 2 trials, one right after another, or the other, and we have red occurring on the first spin and cyan on the second spin. Now, I'll say that again. Alicia is going to spin, and we're thinking about what's the probability that this is going to happen. So what is it that we want to have happen, or think about the probability of it having occurred. So you just think of it as if it did, like you try to imagine it happening. So Alicia spins and it lands on red on the first spin. And then she spins again. And then on that second spin, it lands on cyan. Now, the reason I'm taking the time to really point out the phrase and then, or really emphasize the phrase and then, is when you can reword things using that phrase, it means that you want to use the multiplication rule of probability. So because we're interested in something happening first and then something else or anything, it could even have been red and then red, but because we're dealing with this happens and then that happens, it's a multiplication rule problem. And I'm spending the most time on this because that's really the tricky part about this question. If you didn't realize that the multiplication rule was appropriate here, there'd be no way for you to get the question right, even if whatever math you were doing was correct math. It would have to be the right theory or probability methodology for you to get the question right. So oftentimes, you may have figured this out by now, when you are reading a probability question, the challenge is in interpreting the scenario and then matching that set of circumstances to the correct probability rule or formula. So now that we know it's the multiplication rule, because we have multiple trials in a row, and we've been able to use the phrase and then, now we can think about each individual trial and what's possible on those trials. Okay, so on the first spin, the first trial, we want it to land on red. There are 3 red sections out of the 6. So in other words, half of the sections are red. So the probability could be written out as 3 divided by 6, or that reduces to 1 out of 2, or in other words, half, 0.5. So as a decimal, 3 out of 6 will reduce to 0.5, but since they wanted this to be a fraction in simplest form, we'll go ahead and put it as 1 over 2, or 1/2. Okay, so I'm going to actually enter it into this cell using the equal sign, and I'm going to do 1, actually, you know what, I'm going to do it with text, because if I put it in using the equal sign, it'll change it to a decimal, and I don't necessarily want that. But I will underneath it do that, because I'm going to do the multiplication with decimals and then just confirm that it matches what I think it should be using the actual fractions. Okay, so we have 1 over 2 for the first trial, right? And then the second trial is what we want is cyan, which there's only 1 out of the 6. Now, when we think about the fact that there's only 1 out of 6, this is the probability most likely is 1 divided by 6 for it to land on cyan. But because we're dealing with something else was supposed to have happened first, we want to consider whether or not having the first spin land on red changes the probability of cyan on the second spin. In other words, by when it landed on red on the first spin, did that mean that I could no longer have it land on red for the second spin? So that would take out one of the possibilities, and then it would um, there would be only 5 possible sections. So then would that mean that your probability of landing on cyan was greater because one of the other sections had been removed? So would we use 1 out of 5 for the second trial instead of 1 out of 6, since if it landed on red and we can't use that red anymore, then we only have 5 sections total on the second spin. And I'm asking the question. I'm not saying that's what we should do, but this is the way that you want to be thinking with probability. You want to ask yourself, now on this second trial, has anything changed from, the beginning of this situation? And if they are independent trials, then there will be no change. In other words, um, this scenario is independent trials because you've played games with spinners before probably, right? And if you spin and it lands on red, you know that you could spin it again and it could again land on red because you don't remove sections of a spinner, right? That's just not how it works. That whatever section the pointer landed on the first spin is going to still be the same on the second spin. I mean, it's still going to be there on the second spin. So that means that the probability is not affected by what happened on the first spin, right? The probability on the second spin is not changed based on what happened on the first spin. So that's called independent trials. All right, so that means that we do want to keep it as 1 over 6 instead of 1 out of 5, because we still have 6 sections total that we could land on that second spin, and only one of those 6 is cyan. Now that we have the probabilities for each of these, we want to multiply them. Now, with fractions, you multiply the numerators, in other words, the first number in your fractions or the top number of your fractions together, and then the bottoms or the denominators together. So I want to do 1 times 1. That would give me 1. And then in the bottom, 2 times 6 is 12. So my answer should be 1 out of 12. And I know I'm going to enter it as a fraction here, and I want to make sure it's reduced. And so anything with 1 in the top is already reduced form. Another way of looking at it is there's nothing that divides evenly into both the top and bottom of my answer. So there's no common, factor that needs to be reduced. It's 1 out of 12. That should be the right answer if I've thought through this all correctly, and if I did my multiplying of fractions correctly. Now, if you're nervous about dealing with fractions, you can do it in decimal form and just confirm that the 2 equal out to the same decimal number. So in other words, 1 out of 12 is 1 divided by 12. As a decimal, that comes out to 0.08333 repeating. So now I want to see that if I multiply the first decimal 1/2, which is 0.5, times the second decimal 1 out of 6 as a decimal is 0.16666 repeating. If I multiply those two together, notice that I do get exactly the same answer. So I just like to show there is a way to be confident that you have done your math correctly if you're nervous about working with fractions. All right, so that should be it. I'm going to go ahead and submit it. Cool. So I got that one right. Now, part B. We're going to move a lot more quickly through these other two parts because I've already explained all the things that you need to understand um, as far as thinking through these. So part B says find the probability that Alicia spins cyan on the first spin and red on the second spin. So now we want to just kind of, not kind of, but we're going to reverse the order of the events. And it actually won't make a difference here because of the fact that we have independent trials. So if this had been a situation where we were not allowed to use that one red section again in the second spin, then we would have had possibly a different answer. But actually, another thing that's happening here is um, when you multiply numbers, you can reverse the order of the multiplication and you get the same answer, right? We all know that if you do 2 times 3, you get 6, right? So if 2 times 3 equals 6, then does 3 times 2 also equal 6? That's kind of the point I'm trying to make, is that since we're going to be using the multiplication rule for this question, it does not make a difference that in the second part of this question, instead of red being the first outcome, it's now cyan and then red on the second spin. It's actually going to work out regardless of even if they were independent or not trials. The answer should be exactly the same. Okay, so that one's done. And then part C, find the probability that Alicia does not spin cyan on either spin. Okay, so in other words, there's 5 sections out of the 6 that are not cyan. So if I want to have not cyan on both spins, that would mean that I'm going to do 5 out of 6 on the first spin, so 5 divided by 6 on the first spin. And then I want to multiply that times 5 out of 6 on the second spin. Now remember, when you are multiplying fractions, you multiply the tops together and the bottoms together. So this should give me 5 times 5 in the tops would be 25, and then 6 times 6 in the bottom would be 36. And this does not reduce because there are no factors that are common that we could divide both the top 25 and 36. There's no number that divides both of those equally except for the number 1. So that is already in lowest terms, so that should be my answer here, 25 divided by 36. And if I just want to do my little trick that I showed you before, if I want to do 5 over 6, I could even do it all in one go. 5 over 6 like this times 5 over 6. The only difference in how I'm typing it now is I actually have the equal sign active here. When I did it the first time, I put this little apostrophe in front of the equal sign, which just makes everything text instead of an actual calculation, so that I could just see the math rather than have it do my decimal for me. But now I'm going to calculate, since I already did calculate 5 over 6 fraction times 5 over 6 fraction, and I got a decimal answer in Excel. I want to see if my fraction answer is the same as that. So now I'm going to do in the cell next to it 25 divided by 36 and see what that is as a decimal and just confirm that they're the same. So I feel confident in my answer here in fraction form. And there you go. So that is how you do this question, and I hope that was helpful.